Hello students, my name is Abhishek Srivastava. Today we are going to do the Newton's laws of physics of class 11. So we are going to start with Newton's laws. So Newton's first law of motion. When a body is in motion, it continues to remain in motion. When a body is in rest, it continues to remain in rest. When a body is moving in a certain direction, it continues to move in that particular direction unless an external force is applied to change its present state. This is known as Newton's first law of motion. It is based on law of inertia. So a question comes to us: what is inertia? Inertia is the tendency of a body to continue its present state and opposing a change in its present state. So if a body is in rest, it continues to remain in rest. When a body is in motion, it continues to remain in motion. So there are three types of inertias. Inertia of motion: when a body is in motion, it continues to remain in motion. For example, from our day-to-day life, suppose there is a bus. In the bus there is a person sitting and the driver is driving the bus. The bus is moving with a speed, and at a certain point the driver tries to stop the bus. As soon as he stops the bus, the passenger tends to fall in the forward direction. So why does the passenger falls in the forward direction? This is a question that comes to us. So it is based on law of inertia, because initially the bus was in motion. So the passenger's lower part of the body was also in, which is in direct contact with the bus, was moving in the forward direction. And when it stops, the lower part of the body which is in direct contact with the bus stops, and the upper part moves in the forward direction. It still continues to move in the forward direction because of the law of energy of motion. So the body tends to fall in the forward direction, the upper part of the body, and therefore the passenger tends to fall in the forward direction. The next is the law and inertia of rest. When a body is in rest, it continues to remain in rest. For example, there is a bus, a passenger is sitting in the bus is uh, not moving. Then suddenly the driver starts the bus and the bus starts to move. As soon as the bus starts to move, the passenger tends to fall in the backward direction. So a question comes to us: why does the passenger falls in the backward direction? The passenger falls in the backward direction because of the law of inertia of rest. Because the person was initially in rest and he tries to continue its state of rest, and but the bus has starts moving, it has come into motion. So the lower part of the body of the passenger is in motion, whereas the upper part is still in rest because of an issue of rest, and tries to continue its rest state. So it tends to fall in the backward direction. Now there is the next is the inertia of direction. So the example for this is: a person is sitting in a bus. The bus is moving in a straight road, and suddenly a turn comes and the bus moves towards the right side, but is the person tends to fall in the opposite direction. Why does he tends to fall in the opposite direction? This is the question that comes to us. So the answer for this is the inertia of direction. Because initially the bus was moving in a straight line, the passenger was also moving in a straight line along with the bus, but as the driver turns it to the right side, so there is the lower part of the body has changed its direction, but the upper part is still continuing in the straight direction. Because of the inertia of direction, it is continuing its initial direction. So it tends to fall as if it appears that it falls in the opposite direction, because in a way it is moving in the straight direction, it is still continuing in the straight direction. So this is due to inertia of direction. So now I think you all might have understood the Newton's first law of motion. So now we are coming to Newton's second law of motion, when according to which the force applied on a body is directly proportional to the rate of change of momentum. From this we derive the expression also. So according to the statement of Newton's second law of motion, F is the force applied, so it is directly proportional to the rate of change of momentum dp upon dt, where p is the momentum. So this is the statement of Newton's second law of motion. So we can write dp is the momentum, so we can write mv. It is the product of mass and velocity upon dt. Mass is constant, so it comes out of the integration. So it is mdv upon dt. So dv upon dt is the rate of change of velocity. Rate of change of velocity is acceleration. So we can write it as F is directly proportional to ma, where A is the acceleration of the body and m is the mass of the body, and F is the force that is being applied on the body. So there is proportionality sign, so we can write it as F is equal to kma, where k is a constant. For simplicity, we are taking k is equal to 1. So here putting the value k equal to 1, so the expression becomes F is equal to ma. This is the formula for Newton's second law of motion, and it can be explained as, if a body is having a mass m and an acceleration a, then the force applied on the body will be F. So it is the product of mass and acceleration. Though this is the Newton's second law of motion, we can understand this. According to the Newton's second law of motion, the force is directly proportional to the rate of change of momentum. That is, F is directly proportional to dp upon dt. So F is directly proportional to d, and substituting the value of p is the momentum, which is product of mass and velocity. So it is mv. So here mass is constant, so it comes out of the differentiation. So m dv upon dt we can write. dv upon dt is the acceleration, the rate of change of velocity. So F is directly proportional to ma, mass into acceleration. So here equal to sign, when we take a constant, suppose k is a constant. So F is equal to kma, where k is equal to 1. For simplicity, we are taking, so F is equal to ma. This is our expression. So it is the product of mass and acceleration. This is the Newton's second law of motion. Now we are coming to Newton's third law of motion. To every action there is an equal and opposite reaction, and action and reaction act on different bodies. This is the statement for Newton's third law of motion, and various phenomena are based on Newton's third law of motion. We can understand them. So I'm rubbing the bone. So we can write it as, suppose there is a boat. This is a boat, and here there is an edge of the boat. A person is standing on the edge of the boat, and there is a river. This is the river. The person jumps in the river. When he jumps in the river, the boat tends to move in the backward direction. So we have to tell the reason why does the boat moves in the backward direction. So this is based on law of Newton's third law of motion, action and reaction. the person jumps in the river. When he jumps in the river, he gets the force when he exerts the force from his feet, and then he jumps into the river. So the force that is being exerted on the feet, that is his action, and because of that is its action, because of which the boat moves in the backward direction, and he jumps in the forward direction, that is his reaction. So this is based on Newton's third law of motion, action and reaction. So now there is also, suppose there is a gun, this is the gun, and here a bullet is fired from the gun. Suppose this is the bullet. Bullet is fired from the gun at a very high velocity. Then this is its action. This is its action according to Newton's third law of motion. What will be its reaction? The pistol or the gun is going to move in the backward direction. So that is its reaction. So it is based on action and reaction. So this is also an example of Newton's third law of motion. So now we are coming to the law of conservation of linear momentum. According to the law of conservation of linear momentum, the momentum before the event is equal to momentum after the event. So we can write it as, suppose, so we can write it as m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Here m1 is the mass of first body, m2 is the mass of second body, u1 u2 are the initial velocities of bodies. Initial velocities. V1 and V2 are the final velocities. So this is the Newton's, this is the law of conservation of linear momentum. m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So we are going to do a question based on this. So I'm writing the question. Two bodies of masses 1 kg and 2 kg moving with velocities 1 meter per second, 2 meter per second and 1 meter per second respectively. After collision, both bodies stick together and move with common velocity v. Find v. So this is our question. We are going to read the question and we are going to understand it, and then we are going to do the question. Two bodies of masses 1 kg and 2 kg. So here what is given to us, m1 is equal to 1 kg, the mass of the first body, and the second body is 2 kg, so m2 is equal to 2 kg. Moving with the velocities 2 meter and 1 meter respectively. So the first body, the initial velocity is 2 meter per second, and the initial velocity for the second body, that is, according to question, is 1 meter per second. So I think you all might have understood this much. The first body is of mass m1 of 1 kg, the second body is m2 of 2 kg, moving with the velocities 2 meter per second. So the initial velocity for the first body is 2 meter per second. u2 is 1 meter per second, initial velocity for the second body. And we have to, and the final velocities v1 and v2 are equal to v, because the body sticks together and moves together. So we have to find this final velocity v. So according to the law of conservation of linear momentum, we can write m1 u1 plus m2 u2 equal to, if they are moving with the final common velocity, so it becomes m1 plus m2 into v. So we have to substitute the values for in this expression. So it is m1 is 1 into u1, that is 2, plus m2. m2 is 2 and u1 is 1. u2 is 1. m1 plus m2. So it is 1 plus 2 and into v. We have to solve this expression to find v. So it becomes 2 plus 2 is equal to 3v. So it becomes 4 is equal to 3v. v is equal to 4 by 3. So this is our answer, 4 by 3 meter per second. So both the bodies stick together and they will be moving with the common velocity of 4 by 3 meter per second. This is our answer. We are going to understand this once more. According to the law of conservation of linear momentum, m1 u1 plus m2 u2 is equal to m1 plus m2 into v, because the two bodies have stick together and are moving with the common velocity. So substituting the values, m1 is 1, u1 is 2 meter per second, so 1 into 2, plus m2 is 2 kg and u2 is 1 meter per second, so 2 into 1 is equal to m1 is 1 kg, m2 is 2 kg, so 1 plus 2 into v is the final velocity. So simplifying this, 2 into 1 is 2, 1 into 2 is 2, 2 into 1 is 2, 2 plus 2 is 4, and here 1 plus 2 is 3. So 4 is equal to 3v, v is equal to 4 by 3 meter per second. It is in MKS unit. So I think you all might have understood this question. So please watch this video till the end, subscribe me and press the bell icon. Thank you.